Team 90, Fall 2018 by Craig Moore, Adrian Grimeau, and Bryce Biermeyer. The hovercraft was a prime example of the design process. First off, we had to identify the problem to be able to design, program, and build an autonomous hovercraft that could complete a course. We had a budget of $300 and many criteria for the specifications of the craft. Secondly, we had to gather information. We brainstormed some options and asked around about suggestions for the craft. We read up on the specifications of deck size, prices, weights of parts, different types of batteries, and worked together as a team to come up with different options. For the third step, we analyzed the different options. We chose weight distribution propulsion over a thruster fan because it seemed much easier to design, along with being cheaper and more effective. When deciding between a larger, heavier hovercraft versus a small, light one, we chose to go with the larger one because it offered more room for error. We chose to use foam as the deck material because it was cheap and easy to work with. We chose a 24 by 20 rectangular shape because it was easier to measure and design than an abnormal shape such as an octagon or circle. We chose a 4-fan design in order to supply the high airflow that would be required for a heavier hovercraft. For the fourth stage, we designed the craft, built it, tested, and had to redesign many times. Our first problem was with the stabilizers. We had planned on using Hot Wheels on rods that would move up and down, supporting the hovercraft while hovering and being out of the way when it was down. However, the Hot Wheels did not provide enough traction to hold the craft in place at all. We had found last-minute success with tying coffee creamer containers and rope to the craft, which acted as anchors to hold it in place. While it worked for the test, we knew it would not be enough for the rest of the project. After, we found a toy tractor with medium-sized rubber wheels. We decided to cut off the wheels and use them for the new stabilizers. We thought they would be a good choice because they were rubber, so they would keep traction on the table and keep it from drifting. We ran into yet another problem when trying to attach the wheels. We didn't have enough room to mount the wheels. The hovercraft was already 21 inches long and it had to be no more than 24 inches. Our solution was to mount the stabilizers on the inside. We also decided to elongate the axle for the wheels by using a metal rod. We could not remove the original axle from the wheels, so we had to find a way to join the axles together. We did this with the help of the spray tube from a Windex bottle. We finally had our stabilizers finished and they worked very well. The next problem we ran into was that the bottom of the hovercraft was uneven from cutting it with a knife, so there was uneven airflow and some parts of the craft did not hover. We fixed this by cutting out a poster board in the shape of the perimeter of the plenum chamber and glued it to the bottom. We made it thick enough that it stayed flat and used tape to fill any holes that remained between the foam and the poster board. The next problem we had was with our propulsion system. The motor we purchased was very weak and did not have enough power to release the weight. We messed around with it and found that if we used the motor to swing an arm that acted as a gate, we could get it to work. To reduce the necessary angle of the ramp and reduce pressure on the motor, we taped our weight to one of the Hot Wheels we had for the original stabilizers. After working with the positioning, we got it to work. The fifth part of the design process is being able to communicate solutions to others. Because we worked as a team, it was essential that we were able to communicate our ideas throughout the entire project. Without being able to communicate what we were thinking, there would have been no way for the hovercraft to be successful. After dozens of hours in the EDL and at the dorm working on the hovercraft, we were able to design a successful hovercraft that flawlessly completed all checkpoints and the final competition in 31 seconds. Engineering 100 changed our overall impression of engineering by demonstrating the importance of working as a team. In high school, most group projects could be completed by one person. In this class, that is not the case. By working with each other, we were able to see the benefit of building ideas upon other people's ideas. Doing so led us to implement effective designs in our craft. Considering the small scale and relative simplicity of this project, it has shown us that larger, more complex problems require a large team effort to complete. At the start of Engineering 100, we wish someone would have told us about the importance of patience. We ran into several problems throughout the project and often did not find simple solutions. Patience was extremely important when it came to redesigning the craft as well as when working with each other. Our greatest challenge when it came to our craft was designing our stabilizers. In order for the craft to complete the course, our stabilizers had to be effective or the craft would not travel in a straight line. To overcome this challenge, we implemented the design process, which ultimately led us to use 3 different stabilizer designs throughout the life of the craft.